Hello guys, my name is Mohi and I'll be explaining distinction task 1 and HD task 1. So for distinction task 1, we first create a function, we name it dtask1 underscore f, where v and theta are the input and then distance is the output. Then we have this height, gravity, all variables which we got from ctask1. We have time is equal to the function of linspace. Linspace is to generate a time interval from 0 to 10 seconds. So when we run the function, our time will constantly change. So where our variable x and y will change as well with respect to the time. So if 0 is greater than y, after that sets position, all the y values will be 0. So basically we won't have any negative y values. We'll convert all negative y values to 0, and then we find the last column of the y. We use the find function to find the last column of the y, and if the last column of the y is 0, then our y1 is 0. Then we use if loop is empty. Is empty function basically, if our y1 is non-zero, is empty will say not true, which is not true means 0, binary code not 0. So 0 is equal to 0, so this will run. Distance is equal to nan, display the ball does not hit the ground in 10 seconds. If it's empty, if it's 0 and it's empty, then it will run this function, this one, the down, I mean this coding, the below one, else, and the ball does hit the ground in 10 seconds. Then we have v is equal to the input. We use v equal to input function, so we can input any velocity in the command window. For theta is equal to 0 to theta is constantly changing from 0 to 60. So we plot, we have x, which is x function, which is depending on the variable theta plus 1, and y function, which is depending on variable theta plus 1. We need theta plus 1, so our x and y changes constantly. So they are same size and shape, x and y, so we can plot them. So x is equal to theta and y is equal to dtask1 underscore f, and this input, this is nothing but the what you call the distance, output distance. So we plot a figure between theta and distance. So we name x as angle and y as distance. We label y as distance, and title is ball trajectory. So now you can see here is the legend part. So we can see the ball trajectory, when we insert velocity 4, we can see the ball does hit the ground in 10 seconds, and when we enter the velocity 60, this is the plot we get. The ball does hit the ground in 10 seconds, does not hit the ground in 10 seconds, I mean. High distinction task 1, we have height, velocity, gravity, and then L is the what you call interval. So times 0 to 20 seconds at this interval rate, score initial score 0. Okay, so we create a figure. Now we create a figure, okay, to where we say title ball shooter game, and score display is equal to score number to string. So position of is equal to, we use text function. Basically text function, what it let you does is text plot a text on I mean to have a text on the plot at the coordinate of 3 x-axis and y2 axis. At that point, at that position, the score will be displayed. So we have x limit and y limit. So when we run the figure, will have a boundary at the from x starting from 0 to 4 and y starting from -1 to 2.5, y axis starting from -1 to 2.5. Then for board, we have length of the board is 0.5, board start is run die 2, that means it will generate any random number between 1 and 2. So board n will depend on this thing, 0.5. If it's 1 plus 0.5, board is x-axis of the board, so board start and then till 0.01 till board end. Then we have board level, zeros, so we want our y-axis to be zeros, but it should match the same size as board. So we use this thing, bracket, parenthesis, so that our all the y column and value will be 0 0 0. Then we use this twist, L2 is equal to board length divided by 3, so our L is equal to L2 by 2, radius is equal to L2 by 2. This is just a twist of by giving a value for the radius. Then we create a hold on board position. We plot the board position. Board is the x-axis and board level is the y-axis. These are just for the this thing, what you call the design. Then we have ball position. We plot t. You can see that there is 1 here. This is the initial time, so we can't just leave it as t. So we need the initial time because t is in matrix format. So we need the starting of the time, and then this is the height in this thing. Okay, so we hold off. Now we have play is equal to 1. While play is equal to 1, we will display this, welcome to the shooting game. Display the to leave the game into x. Theta is equal to the function input. We can input any value from -90 to 90 degree. Then if theta is equal to x, our game, we display your final score and display thank you for playing. Play becomes 0, and when play becomes 0, our while loop shuts down because our while play is not 1. Then we create boundaries so people don't enter the wrong value. Is letter, we use is letter to create, if anyone enters letter ABC instead of any value, it becomes true, so we display this. And then if any guy less than -90 or more than 90 degree, we display this one. If it's an imaginary number, we display this one. Okay, so now we go for else. Theta is equal to 2 string, y is equal to height, k is equal to 0, touch is equal to 0, timer is equal to 0. So we create a for loop where our I is constantly changing. I is equal to from 2 to length function, so maximum of time, variable time, maximum of variable time. Then we create if, you can see this is the condition where the ball touches the board. We create a condition where ball touches the board, and when it touches, our touch becomes 1 and our timer becomes +1. So if touch becomes 1, we have here touch is equal to 1, our k also becomes 1, and then we have a command here for the y-axis. So what happens after the ball touches the board? This is the command for that. If it's minus here, the ball will fall down and hit the ground after touching the board, slide and fall down, and if it's plus here, the ball will bounce back from the board and go up. Okay, if the ball did not touch the board at all, we'll run this command where for the y-axis, so the ball will fall. Then we use the draw now function to animate, so that our x-axis and our ball are animated. Okay, and we use the set function so that our x data will constantly change with the variable of x, and y data will constantly change with the variable of y, and then this will for animation. Okay, then max, if max y is -2 and -1.1 is greater than -2, so the game resets itself. So our ball position will go back to the initial position, x data 0 and y data h, and we'll pause for 1 second, as well as the board position will reset. Then we can see that the positions, we'll use set function for the board x data, only changing the x data, we do not change in the y data, because y data is always 0. We always want that. Then we will break the game shutdown, we have to play again. If the ball touches the board, we run this one as well. So if the ball touches the board for more than 0.020 seconds, our score becomes score +1. Then our set function will display the new score in it, and then fprintf will show the current score that you have scored. And this is it. This is the end of the whole script, and this is how it looks, the diagram, when you play the game. This is how it says thank you for playing when you exit the game. Thank you so much for listening. That's it.